Today we're going to go over lesson 6 of our congruent triangles unit, which covers isosceles and equilateral triangles. The last time we met, we talked about isosceles triangles, and I mentioned that they are triangles with two congruent sides. The congruent sides are called the legs, so this side would be congruent to this side, and the included angles of the legs is called the vertex. So this would be the vertex, angle 1. The other side is called the base, and the two angles across from the congruent sides are called the base angles. So angles 2 and 3 would be base angles, where angle 1 is the vertex. Last time we met, I mentioned the theorems that are associated with isosceles triangles. The first theorem is that if you have an isosceles triangle and you're given, or if you have a triangle and you're given that two sides of the triangle are congruent, then the angles opposite these sides are also congruent. So since segment AC is congruent to segment CB, then the base angles are congruent. And vice versa. If you're given two angles of a triangle being congruent, then we could say that the legs that are associated with these two triangles are also congruent. You want to put this in your toolbox because we'll use this in proofs later. There are also theorems associated with equilateral triangles. Okay, a triangle is equilateral if and only if it's equiangular. So if all three angles of a triangle are congruent, then it is also equilateral. So if all three angles are congruent, then all three sides must also be congruent. And vice versa. If you're given a triangle where all three sides are congruent, then all three angles must also be congruent. Okay, these two theorems, or these four theorems we just discussed on isosceles triangles and equilateral triangles, will definitely come in handy when we're trying to use our to prove some proofs later on. So on number 1, refer to the following figure to answer the following questions. A, name two unmarked congruent angles. So look at this figure and see if you can figure out what two unmarked congruent angles are. Okay, so looking at triangle CBD, we know that since these two angles are congruent, then the legs that are associated with those two angles are also congruent. So we know that BD is also congruent to BC. So since CBD is, since CB and BD are also congruent to CB and BA of the other triangle, then these two triangles are congruent, right? Okay, because we have angle, angle, side, angle, angle, side. So since these two triangles are congruent, then we could say that two unmarked congruent angles could be angle CBD and angle CBA. Pardon my penmanship, it's really hard to do this on the laptop. Okay, the second problem says name two unmarked congruent sides. Well, we've already done that with number 1. Well, no, we haven't named two unmarked ones. So, okay, try to do this one on your own real quick. Okay, since we already said that triangles CBD and CBA are congruent, then we also know that side CD is congruent to segment CA. Okay, CD and CA would be the what of both of these triangles, since they're isosceles triangles. They are the bases. Good. Number 2, find the measure of each. Okay, find the measure of angle R. So I want to know the measure of this angle here. Try to do it on your own. Okay, using the theorems that I gave you a moment ago, we know that since this side here is 5 centimeters, and since segment PQ is 5 centimeters and segment RQ is also 5 centimeters, that angles P and R must be congruent, right? Because these two sides are congruent. Okay, so since these two angles are congruent and this angle is measure angle 60, we know that these have to add up to be what? 120, right? So the measures of a triangle are 180 degrees. So what's 120 divided by 2? 60. Good. So the measure of angle R is going to be 60 degrees based on the triangle sum theorem and also the isosceles triangle theorem. What is the measure of side PR? This segment here. Well, since both of these angles are also 60 degrees and this angle is 60 degrees, then we can use the equilateral triangle theorem, right? And we know that side PR has to be what? 5 centimeters. Good job. Number 3, find the value of each variable. Here I want you to solve for x and solve for y. I'm going to give you a few minutes to do this on your own. At this point, if you're not finished, please press pause before I continue. Okay, so the first thing that I would do here is I would solve for y, because I know, according to the markings on my triangle, that this segment is congruent to this segment here. So we know that 4y is equal to 2y plus 2. So, 4y minus 2 is equal to 2y plus 2. Okay, solving for y, I'm going to bring my y's onto this side of the equation, so I get 2y is equal to 4. Divide both sides by 2, and I get y is equal to 2. Now, how are we going to solve for x? So the only thing I have about, I know x belongs to an angle. The only thing I have about the angles on a triangle is that this angle here is 80 degrees, and this angle here is 6x plus 8 degrees. Well, knowing that these two sides are congruent, that I know by the isosceles triangle theorem that this side is also congruent to this, this angle is also congruent to this angle, right? Okay, by knowing that, I know this angle is also going to be 6x plus 8. So what do we know about the sum of our angles of our triangle, the interior angles of our triangle? They add up to be 180 degrees, right? So what I have is I have 80 degrees, looking at the vertex of my isosceles triangle, plus 2 angles that measure to be 6x plus 8. So I'm going to do 2 times 6x plus 8. Okay, and then I'm going to set that equal to 180 degrees. Okay, when I solve for x, I get 12x. I'm going to bring x on the same side of the equation. I get 12x is equal to 84. And then I get x is equal to 7. Okay, so x is 7 and y is 2. Okay, in the last problem of this lesson, I want you to find the value of each of these variables. Here we have variables x and y, so make sure you solve both x and y. I'll give you a few minutes to do this on your own. Press pause now so you can work it on your own. Thanks. Okay, so the first thing that I see here is that segment DF is congruent to segment EF by these the congruence markings here. So I know that 6y plus 3 is equal to 8y minus 5. When I solve for y, I end up getting that 8 is equal to 2y, and then y equals 4. Okay, now when I want to solve for x, I see that x is talking about the measures of angle F and then angle E. Okay, so since angle F and angle E are both the same, 4x minus 8, then we know that they are congruent, correct? So these angles are congruent. Since these angles are congruent, what do we know about these two sides here? They're also congruent, right? Well, if all of the sides of my triangle are congruent, then what does that tell me about the angles? They're all congruent, right? And so for all the angles in the triangle to be congruent, they all have to equal what? 60 degrees. Good. So, whenever I solve for x, all I have to do is set 4x minus 8 equal to 60 and solve for x. Okay, and when I solve for x, I get x is equal to 17. Okay, so today you learned 4 new theorems that will help you in solving problems about triangles. You have some homework problems tonight to do from the textbook, so do those, and then tomorrow you will get a handout in class. Thanks.